Okay, so let's take a look at some actual applications of some of the complex numbers in AC circuits. So AC circuits, like we said, are dependent on time. So that's where we get our time variable right there. So they give us AC voltage source has that equation. Find this voltage in the rectangular and phasor forms. Okay, so from this, we need to go pick out some key pieces of information. So Vm, like we said, here we'll write this over to the side. So V of t will be equal to Vm cosine omega t plus theta. So if we match these two up, we'll see that Vm is going to be equal to 25. Our omega will be equal to 30 degrees, volts, degrees. Then our omega will be pi. This will be radians per second. So it's everything that's before the t is what your omega is. And it's in radians per second. So all we need to do for the phasor form is we'll say Vt equal to Vm at our angle. So V of t will be equal to 25 volts at 30 degrees. Rectangular, all we need to do, V of t is just V of m cosine of theta plus j V of m sine theta. So this will be 25 cosine of 30 plus j 25 sine of 30. I'm getting 21.65 for the real part, and the imaginary part is 3.35. V of t. All right, and that's all we have to do. Moving on here, let's take a look at what we got. So we have the. I just want to make sure everything was finished. Okay. So here we have an AC circuit, current source. So now it's a current source instead of a voltage source. A-okay. But now they give this to us in the complex form, and they want us to find this in the rectangular form and the sinusoidal form. So let's go ahead in our frequency of 60 hertz. So let's go ahead and pick out what we need to pick out from this. So from here, I of m is going to be equal to 9 amps. And my angle is going to be 30 degrees. They give me that frequency is equal to 60 hertz. But we don't work with hertz, we work with radians per second. So I need to change that. And using our equations from the concept video, so frequency is equal to 1 over the period. But we also know that omega is equal to 2 pi over the period. So if we combine those two, we will get the angular frequency is equal to 2 pi times the frequency. So 2 pi times 60 hertz. That'll give us 120 radians per second. So now we can go in and piece everything together. Let's go ahead and write the sinusoidal form first. So if we do I t is equal to 9, and I'll write it up here for you. So I of t is equal to I of m cosine omega t plus theta. And notice something I forgot to point out, but notice here, cosine, there, cosine, they need to be in cosine because we want to work with the real part of things. Real parts are useful to us. So 9 cosine, our omega, 120. Drop our t in there. And then add our phase angle, which is 30 degrees. There we are. And if this was a negative phase angle, all we would do is just replace the positive with the negative in front of the phase angle. Okay. So this is our sinusoid equation. Okay. Now for the rectangular, similar to the previous problem, all we'll do is the magnitude cosine of theta plus j magnitude sine of theta. So 9 cosine 30 plus j 9 sine 30. That gives me 7.79 for the real parts. So, 9 cosine 30, 7.79, and then 9 sine of 30. And that gives me 4.5 for the J. And there we are. And it's just like that. I'm going to post one more video in this playlist, and it's a useful trick that I like to use, and it's going to relate to the complex numbers, converting back and forth using the scientific calculator. So that'll be the last video in this playlist. Hopefully this cleared some stuff up for you, gave you a quick refresher. I'll see you in the next video.